All right, in this lesson, we're going to be talking about common logs and natural logs. So a common log, that's base 10. A natural log, that's base E, base E. So if I have log 2 to the 8, we know that's 3. That's got a base of 2. But if I say log 100, this is a common log. That's base 10, because there's no base written. So it's a 10, kind of like a square root, there's no 2. 10 to the what is 100? That's 2. So on the calculator, if you just hit log by itself, that's base 10. But if it's log base 2, you either have to do log 8 divide log 2 to get 3, or if you got the new operating system, you do that, you get 3. Okay, so log base E, they don't write base E, and they certainly don't write 2.714, whatever that number is. See, E is a magic number, second to E1. It's that number. It's an irrational number. It's found everywhere. It's found in statistics with the normal curve. It's found in a lot of exponential growths follow it. Compound interest follows it. All right, you could talk about E for days, but we don't have a lot of time, so we're just gonna kind of do the stuff. But feel free to Google it or watch some pretty cool videos on it to see how it works. But they don't write this. They write ln. So if you see ln 10, well, maybe I won't do ln 10. Like if I say ln of 5, that really means log base E to the 5. So ln is found here, right here. So if you hit ln 5, enter, you get 1.609. If you hit alpha window second E, well, you got to do that then. But yeah, they don't write. Okay, now this stuff here, log of 56.8. Well, log 56.8, 1.75-ish. Yeah, all right. Find x when log is that. Well, here, so if I have log base 10x is, let's do this one, 2.6. See, that really means base 10. Circle it. 10 to the 2.6 is x. So if I do 10 to the 2.6, I get 398.107. They just don't write the base. Okay, natural log. Well, so if I do ln 56.8, I get 4.04. But down here, find x. Well, that's really log base E, x equals 2.6. E to the 2.6 is x. Second E, 2.6. That's your answer, 13.5. Ten to the what is 0. So, I mean, if you do log 0, it's undefined. 10 to the what is 0, you can never have that. 10 to the what is 1, that's 0. 10 to the what is 10, that's a 2. ln of 1 is 0. ln of E, well, E, you got to do the first power. That's 1. The reason why ln of E is 1 is ln of E, now ln is log base E. See, this blue ln is really log base e. This e right here is going to come here. E to the what is e? 1. Okay, evaluate to the nearest hundred. So I have log 9 plus log 3. 2 ways to do this. Log 9, parentheses, plus log 3. 1.41. Or you could use the properties. That's log 27. Does that give us the same thing? You bet. Okay, so ln of 35, that's going to be 3.56. With this one here, I would do the bottom first. So log 4. Oh, there's a glare. All right, log 4 plus log 14. So then I'm going to do, all right, so 2 log 16 divided by that answer, 1.38. The same thing here. I mean, I could do the properties. 32 over 27. Don't have to, though. So ln 11, parentheses, divide. Make sure you close off those parentheses. That's 14.11. All right, so if log of 5 is a, then log of 5, well, so here, 10, 5 is a, so switch that. 10 to the a is 5. So now this value, here, 1, 2, 3, 4. It's going to be that. And I wouldn't really worry about that stuff. So I'm not really going to worry about this stuff here. All right, let's go to solving exponential equations. So we got to solve these to the nearest 10th. It's not going to be a nice answer here. So circle, add the log. Let's go on our calculator and let's do log 9, 14. Once again, if you don't have the new operating system, it's log 14, enter, divide, log 9. Okay, so that's 1.20, or 1.2. Circle, that's log 2 to the 7 is x. .8. Log 2.5, 9.88. We get this. And same thing there. Okay, there's a couple ways to solve this. When you get to pre-calc, sometimes they might tell you to do this. To get an x out of the exponent, you can do the switch, or you could just do ln both sides. If you take ln of both sides, this comes out front, so we have x ln of 2 equals ln of 7. Divide both sides by ln of 2. So x equals ln of 7 over ln of 2. Now the ln's don't cancel, and we're not going to get 7 over 2. We have to actually do this, so we got to do ln of 7 divided by ln of 2. And we get 2.8. I could also write this as ln of 7/2 if I wanted to, but 2.8. There's another way to do this. I could say, instead of taking the ln of both sides, I could take just a basic log of both sides. This drops down. Drop it like it's what, Tom? Nope. Like it's a power when we're dealing with logs. All right, the power rule. Log 7, divide both sides by log 2. We could evaluate that, and we're also going to get 2.8. This is equivalent to log base 2, 7. It's the same thing. So there's something called a change of base, where if I have log A over log B, I could say it's log base BA. So if I have log 3, 7, that's log 7, log 3. I could also say that. All right, so this one here, let's divide both sides by 6, so we get e to the negative x equals 3 divided by 6 is 1/2. Circle it, add the log. Log base e is really just ln. What's ln of 1/2? Divide both sides by -1. 0.7. So another way to do this one, so you divide both sides, I have negative e to the negative x is 1/2. A lot of textbooks will say if you see an e, just ln both sides, because ln and e cancel. And I'm left with that. So x is going to be negative ln of 1/2, which x is going to be, oops, that's a negative 0.7. See, like this, I could take ln of both sides. That's gone. Add 3 to both sides. Plus 3. Then divide by 5. So I could evaluate that. ln of 10 plus 3, divide 5. 1.1. Equivalently, you could also do circle, add the word log, keep that there. Log base e is also known as ln. Then you keep that 10 there. And I'm right back to where we started. This one, the population of a city grows exponentially with that formula. T is years. When to the nearest year will the population reach 15,000? So 15,000 is 8,500, 1.1 to the t. So I got to solve for t. Divide by 8,500. So 1.7647 equals 1.1 to the t. Now, how do I solve for t? Well, a couple ways here. A couple ways to do this. Actually, no. Let's just ln both sides. So ln of this number, ln of that answer. I get 0.56798 equals t. That t is going to come down, ln of 1.1. So 0.56798 equals t times ln of 1.1, 0.9531. Divide both sides by this, 0.5678798 divided 0.09531. T is about 5.96 years. When to the nearest year? So 6 years. So now we can solve for a variable in the exponent where we never were able to do that before. So kind of with this coronavirus, what they're doing is they're saying, all right, they're using an exponential equation. I don't know what the equation is. All right, it might be 2t, maybe it's doubling every 16 days. All right, so maybe this is the equation to say, all right, well, how long is it going to take before, 10,000 people have this, are infected or something. So then, you would take the ln of both sides. This variable comes down. So I get t over 16. So then ln of 10,000 gets some number there, times both sides by 16, divided by ln of 2. You can figure out how long t would take. All right, the engineer wishes to leave, it's supposed to be a point, 100 grand. What's the maximum number of withdrawals to the nearest month? I don't want to do that. All right, so we got this function here. X is the number of decades since 1990. In what year would the population reach 420 million? All right, so this is already in millions, so I just write 420. 80.21 E 0.131x. So divide by that, and it wants us to solve for x. So 420 divide 8021, 5.23625 equals e to the 0.131x. So once again, there's an x in the variable. Sorry. There is a variable in the exponent, so to get rid of that, ln. So ln of this number is 1.6556 equals, this is going to come down. ln and e cancel out. That's a rule. So ln of e make 1, and if I have e to the ln, that's also a 1. You need to know that. ln and e cancel, but if it's e to the ln, that cancels also, and they make 1. So 1.6556 equals 0.131x. Divide by 0.131, and x is 12.63. So in what year? I don't know, 13th year. Well, all right, x is the number of decades, so I don't know, 13 decades. All right, so 2000 and, I don't know, 13 decades, okay. And so just more word problems here. All right, video's done.